Okay, now the numerical says a motorbike running at 90 km per hour. So as you can see in the question, they have given you the initial velocity of the bike. But this initial velocity u, as you can see, it is given in kilometer per hour. So what we will do, we will convert it into meter per second. We will multiply it by 5 by 18 and it will be converted into meter per second. Now this bike is slowed down to 54 km per hour. So the final velocity, it is getting 54 km per hour. So we will multiply it by 5 by 18 and we will see it will be converted to meter per second again. By the application of brakes over a distance is given to you s, that is given 40 meter. Okay, now just say calculate the total time in which the bike comes to rest and the total distance traveled. Now from the information given here, first of all we will try to calculate the retardation produced in the bike. So let us calculate retardation produced. Now using these three information that have been given to us, we will be calculating its retardation. So we have v square is equal to u square plus 2as. So v over here is 15, u over here is 25, and then distance is 40 meter. So this will give you 225 is equal to 625 plus 80a. So this will become 225 minus 625 is equal to 80a. So this will give you minus 400 is equal to 80a. So a will be equal to minus 400 upon 80. So retardation, see, acceleration is negative, so you can say that there was a retardation. So the retardation is minus 5 meter per second square. Now this retardation was produced over a distance of 40 meter. Now they say the brakes are applied with the same force. Brakes are applied with the same force, that means retardation remains constant throughout the motion. Now we have to calculate the total time in which the bike comes to rest. Now as the bike is coming to rest, so that means final velocity to be taken as 0. See, initial velocity remains the same, 25 meter per second. But now the bike is coming to rest, so final velocity will be taken as 0. And as the question says that brakes are applied with the same force, so that means retardation remains same throughout the motion. So a is equal to minus 5. It remains the same throughout the motion. Now first of all we need to calculate the time in which it will come to rest. Okay, now let's use this information. We will be using the formula v is equal to u plus 80. Here v is 0, u is 25, and the acceleration is minus 5, and then we have to calculate the time. So 0 is equal to 25. This will give you minus 5t. So we are getting 5t is equal to 25. So time is 25 upon 5, that is equal to 5. So that means the bike comes to rest in 5 seconds. And now we need to calculate the total distance traveled. What we need to calculate is total distance traveled. So let's calculate the total distance traveled. So to calculate the total distance traveled, you can use the formula s is equal to ut plus half at square. So S is equal to U. Initial velocity is 25. Time we have calculated 5 plus half. Acceleration is negative 5 into t square. Time is 5. So you will get 25. This will become plus minus minus. Sorry, 25 5 125 minus. This will give you 25 into 5 125 upon 2. So we will be getting the result 125 minus 62.5. So if you subtract this, you are getting 62.5 meter. So this will be the distance traveled. Hope this is clear to you now. Okay, so now in this question they say a stone thrown vertically upwards takes 4 seconds to return to thrower. See, stone is taking 4 seconds to go up and then to return. Remember, in such questions, time taken by a body to reach the highest point is equal to time taken to come back. So total time given to you is 4 seconds. So that means out of these 4 seconds, it has taken 2 seconds to reach to the highest point. Now we are doing the calculation while body is moving in upward direction. Body moving in upward direction. Now as the body is moving in the upward direction and reaching to the highest point, so first of all we will write down the time taken. So time taken to reach the highest point will be 2 seconds, because the total time is 4, so it will take 2 seconds to reach to the highest point. Then body is reaching to the highest point, so final velocity is 0. Final velocity is 0, reaching to the highest point. Now body is moving in the upward direction, so acceleration due to gravity, it will be negative, so minus 10. So we have this information while body was moving in the upward direction. Time we know, at the highest point velocity becomes 0 and a is also known to us. So first part they are asking you to calculate the initial velocity of the stone. So let's calculate the initial velocity of the stone. So we will be using these three informations. So we can use the formula v is equal to u plus at. Here v is 0, u we have to calculate, a is negative 10, time is 2. So we are getting u as 20 meter per second. So we have calculated the initial velocity. Now also we need to calculate the height. So again, using the same information, we can calculate the height. So we can use s, that is the distance in the upward direction. S is equal to ut plus half at square. So we need to calculate s. Initial velocity we have calculated 20, and the time taken in the upward direction is 2, plus half. Acceleration is minus 10, again time is 2. So we are getting it as 40. This will become plus minus minus 5 into 4. So that will give you 40 minus 20. So displacement in the upward direction is 20 meter. So that means the height reached by the stone will be 20 meters. Okay, now in this question they have shown you a velocity time graph. So this is the velocity time graph shown to you. Now in this graph you can see the graph can be divided in two parts. So first part we are naming as AB, and the second part we are naming as BC. So you can see in the first part slope is positive, so the first part is giving you the acceleration. In the second part slope will be negative, so it is giving you retardation. So the first part says you have to calculate the acceleration from this part. Now to calculate the acceleration, so first of all we can see that acceleration is in part AB. So acceleration in part AB. Now how do we calculate the acceleration? So to calculate acceleration we need to find the slope of the graph. So we need to find slope of AB. And how we will get the slope? Formula is y2 minus y1 upon x2 minus x1. So what we need to do is we need 2 points on the graph. So let us consider these 2 points on the graph, A and B. So A is the first point. So whatever will be the coordinates at A, so you can see A is at origin, so coordinates are 0, 0. So whatever will be the coordinates of A, they will be named as x1, y1. The second point is B. Now you can see what are the coordinates at point B. At B, x coordinate is 10 and y coordinate is 15. So we have 10, 15. So the second point will be named as x2, y2. Now using these coordinates over here, we can get acceleration. y2 minus y1, so you can see y2 is 15 minus y1, that is 0, upon x2 minus x1, so 10 minus 0. So acceleration will be 15 upon 10, that is 1.5 meter per second square. So this we have calculated acceleration. Now in the second part they are asking you to calculate the deceleration, that is retardation. So you can see retardation is in part BC. So what we need to do is find the slope of part BC. So retardation is in part BC. So again we need to calculate slope. So you need to calculate slope of part BC. Formula remains the same, y2 minus y1 upon x2 minus x1. Now for part BC, now you see B will be the first point and C will be the second point. So first point B, it has coordinates of 10, 15. So first point coordinates will be termed as x1, y1. Now C is the second point. You can see the second point C, it lies on x-axis. So value of x over here is 16. But as the point is on x-axis, so y coordinate will be 0. So that gives you x2, y2. Now substituting these values. So we have y2 minus y1, so 0 minus 15 upon x2 minus x1, 16 minus 10. So this will give you minus 15 upon 6. So when you reduce it, you are getting 5 upon 2. So 5 upon 2 on simplification will give you minus 2.5. So you can see as acceleration comes out to be negative, it indicates that there is retardation. So when you are writing the term retardation or you are writing the term deacceleration, then don't use this negative sign. So retardation will be 2.5 meter per second square. So this was the velocity time graph. So remember, in velocity time graph, whenever we get the slope, we get acceleration. So in first case we got the slope positive, so it is acceleration. In the second case we got the slope negative, so it is retardation. Okay, we have done the first part, second part. Now the third part, distance. Now how do we get the distance from velocity time graph? So whenever they will ask you to calculate the distance in the velocity time graph, so what you will do, you will calculate area between the sketch and the time axis. So this is, so here we need to calculate area of the triangle. So when we are calculating area of this triangle, you can see the base of triangle is 16 and the height of the triangle is 15. So we will calculate area of the triangle. So we can say that distance will be equal to the area enclosed between the sketch and the time axis. There you are getting a triangle with base 16 and height 15. So on calculating the area, it comes out to be 120. So this will be the distance traveled.